Okay, now I'm going to start question 7, right? Question 7, very nice. I if you give me a choice, I would choose question 7, right? I will do question 7 hands down. Because just looking through, right, it seems to be a lot easier, and I mean, some of you might have issues with what is a head-on collision, right? And calculate ratio of T1 over T2, which is B part 3, So there are quite a number of somewhat challenging questions, right? 7A is 7 is a bit more direct, I think, right, compared to question 6. Anyway, let's go. Let's see what answers are. So 7 part A asks you to distinguish between resistance and resistivity. So here I also improve the solution from Tmjc, right? So resistance, I think we have no issue. Our schools are congruent, right? We state it and define it in the same way. So you have to remember it is the ratio, right, of potential difference across the wire to the current flowing through the wire. Okay. Resistivity is the one that is not so well defined across schools, right? So in our school we define it like this. I think in the notes we define it like this until this part. Um, and TMJC's one was also slightly different, but it essentially meant this. I feel that if you want to be even more careful, you can add in the following line, which is this, right? If you want to define resistivity. Okay, so because once you do this, you have distinguished between the two by showing how they relate to each other. Agree? Right. So I think in this question, it makes more sense to add a little bit more for resistivity. This part, rho equals to A. I mean, R equals to rho L over A, right? So if you turn the equations around, you get rho equals to AR over L. Okay. So definition question, do update your terms and definitions list, right? I think this one not found inside, but do update it. Next, B part 1, calculate the resistivity of copper. Well, you already have it here, you see? Right? The work you have done before will not let you down. Put it in, sub in, you get this answer. So they left the answer to 2SF. I went to check. It is correct. In fact, the answer is 1.70, even if you leave to 3SF. So no problem. They give you an answer 2SF. You can answer is 2SF or 3SF, right? So just sub in, no issue. Part 2 is a bit more interesting, right? Because it asks you to count the resistance of one strand. If you read part B, third line, the resistance of the cable is 3.6, right? I think in the time practice we did something like this. So cable means a number of strands connected in parallel each other, right? That's what a cable is, right? You will never depend your charging or your powering of your laptop or with one cable, right? One strand. No, you will not trust one strand because it might break. That's why you have a few strands in parallel, right? So therefore, uh, you need to know, right, this. So this is something that we have done, I think, in one of the papers prior. Okay, so you get this as 1 over r, where r1 is the resistance of one strand 20 times. Okay, if you do it 20 times, it's basically 20 over r1, all right? So if you then rearrange, r1 must be equals to the resistance of the cable, which is r total, times 20. So you have this, and therefore the answer is 72 ohms, right? No problem at all. Next, part C, right? Describe the variation of resistance of the diode between V equals to negative 0.5 to V equals 0.8. Okay, so you can split into a few parts, right? You can see obviously that the line is practically horizontal until up to 0.45 or 0.4, right? Or even you can say it's very small at 0.5. So you can say that there's very high or infinite resistance to about 0.4, right? For me, I would, if I want to be a bit more careful, obviously I would choose 0.4, right? I think that's the slightly stronger answer. I would say that it's very high resistance or infinite resistance until 0.4. Then I would say that resistance decreases from 0.4. Okay, uh, because the ratio right? Because the ratio of VI drops. Okay, but here if you look carefully, the question only asks you to describe, right? C part 1, the command verb here, use figure 7.2 to describe. That means you don't need to explain why, okay, just state. So resistance will decrease. If anyone of you said that resistance drops to a constant value between 0.6 volts to 0.8 volts, then I will also mark you wrong, because resistance is not constant past 0.4 volts. It drops and continues dropping or decreasing as you increase towards 0.8 volts. All right. So the students will state that the resistance becomes constant at a smaller value between 0.6 volts to 0.8 volts. Usually have this as a misconception, right? So this is something that you should never do. Right? This is wrong. If you have the word gradient or rate, or that the value of the resistance is constant between 0.6 to 0.8, please mark yourself wrong. Okay. Next, calculate the resistance when the current is 0.40 milliampere. Right, this one you must look very carefully. They're asking for 0.40 milliampere, not 4.0 milliampere. So you must be very careful. 0.4 is practically the first square. I thought it's a little bit strange, but okay, they are testing you for the first small square. Right, so if you look at the diagram here, right, it is practically, where's the diagram here? Right, it's practically at here, right at where my cursor is, which is interesting, right? Because if I'm a teacher, I would actually probably set this point at 6. Yeah, so very interesting why they set that value. Maybe they want to catch you off guard, see if students will write 4.0 milliampere, right? Yeah, so anyway, just find it in 0.4 milliampere. The voltage is about 0.55 volts, right? Because it's 10 squares for 0.5 volts. So 1 square away from 0.5 is 0.55. Identify it clearly though, right? I think when you're reading off graphs, you should identify it clearly. See what they're doing it here, right? Always identify the value. Once you have that, state the equation, sub it in. Here, I will also strongly recommend putting it in standard form, just in case they are particular about it, right? Technically, any value above 100 ohms should be in standard form. Okay, so if I show you, right, basically we should write this 1.38 multiply by 10 to the power 3, 1, 2, 3, right? 10 to the power 3. So this would be the better answer, right? Which is foolproof, right? No way for them to deduct marks. Okay. Next, ask you to draw the line. This is the one that you need to be very careful. I think a lot of students make mistakes here. You need to have a straight line here. So I think it wasn't very clear, but you can see that this part is more or less straight, and then you have a curve, right? And when you curve, do not curve it until it's completely horizontal, right? Because that's not how it should be, right? Just curve, let it drop, and then leave it. So there must be a obviously straight part. You use a ruler, right? So if I remove this, you can see that there's a straight part which I penned over, right? Just so that it's consistent. Okay. Right. So these two parts, a straight part and then a curve. Why is there a straight part though? That's actually quite interesting. It's because when the voltage is low, right, the current is low, the energy, right, in the lamp, the energy used up in the lamp is very low, and therefore the filament lamp does not heat up. If the filament lamp does not heat up, it actually behaves like an ohmic conductor, right? That's why there's a straight line portion, right? Very, very important to remember. A lot of students forget about this. They just do the curve part. All right, anyway, part E. They ask you to calculate the resistance of the lamp when the power across it is 20 watts. So if you look at the question here, right, it's 20 watts across this lamp. and the PD across it is V. So this question is kind of like a giveaway because power is P, V is given. How do you find R? There's only one equation that jumps to my P equals to V squared over R. So very nice, the this question. It's like a giveaway, like Santa Claus. Huh? If you didn't do this question, maybe you wanted to challenge yourself. But in exam, I will choose this question anytime over the previous one. Anyway, so 5 ohms, not difficult. Calculate the charge passing through the lamp. So I think there are a few ways. I think some of you would choose to do it this way, right? V equals IR to find the current, then I equals Q over T to find the charge. I think so. That's why I added this in as one of the solutions that you might want to take a look at, right? There's the other way though that I mean a bit less natural, but it's actually faster. Is that using V equals to W over Q? Right, this is one of the definitions, right, of voltage or potential difference, right? So potential difference is the work done in driving one charge across the component. So if you rearrange Q equals to W over V, then work done is just energy. So energy is power times time. So the power is 20 watts, the time is 1000 seconds, the voltage across is 10 volts. You get 2000, right? Again, you get 2000, and like I said, 2000 is larger than 100, therefore you should use standard form, right? The answer from TM, they were not standard form, so I thought, maybe not so good. I took some time to improve them. Lastly, part 3, right? The variable resistor is now adjusted to 2 ohms, and the PD across the lamp is now measured to 2 volts, right? So obviously here, this question, our favorite equation, right, the potential divider principle, has not occurred yet. So one of the key ideas in the mind when you attempt a COE DC question is always to think, hey, maybe can I use a potential divider principle? So potential divider principle means that the potential across the lamp, 2 volts, is the ratio of the resistance of the lamp over the total resistance of the circuit multiplied by the EMF. So once you have that, you realize that in this one equation, there's only one unknown R. The rest is just math, 0.50 ohms. Not an issue. Okay. Lastly, part F, also one of the answers that I improved. You look at it, there's 3 lines, but there's only 1 mark, right? In Cambridge, you will get the same thing, right? Not all marks are of the same difficulty. Some marks are harder to get than the others. So here is quite a challenging. If you read the question carefully, it says, explain how the 2 values of resistance in E part 1, E part 3 provides for the evidence of the shape that you have sketched in part D. Wow. So you must compare 3 different parts. So for me, I will start chronologically, right? I mean, the answer previously by TM don't have all this, so I'll start chronologically. I'll say in the sketch in part D, we see that the resistance increases once the value of V go past a certain point. The ratio of V to I increases. This is the reasoning behind. You may or may not want to include it, right? See if you have time and space on your answer script, right? Yeah. So once you have this, then you know, okay, what am I looking for, right? In E part 1 and E part 3, we see that the resistance of the lamp is higher, right? In E part 1, the resistance of the lamp is higher when the voltage or the potential difference across it is higher. Okay? And that's the answer, right? In E part 3, we see that when the potential difference is low, the resistance is low, right? So very consistent. And that's the answer, right? So essentially, you see how long I took to explain question 7 is a lot shorter compared to question 6. Yeah, so definitely interesting paper, right? For those who were not at the lecture, here is something else. You should probably try question 1, part part 1, and look at the answer for part C, because I think that's a very good answer. You should also look at question 2B part 2, right? One of the commonly forgotten parts of circular motion. Then let's see. I think question 3C part 2 is also quite good. Yes, then question 4 is standard. Question 5A part 2 is very tricky, right? Definitely worth a look. Yeah, the rest are pretty standard, right? Definitely, I think we don't have enough practice with question 5C part 3, right? Using the graph to find the gradient. We don't have enough practice, but yeah, sure. So if you want some practice on that, you can try this question too. All right, thank you. Have a nice day.